Marine climate interventions, the hidden risks, and how to manage them. Our oceans are at a critical crossroads. Climate change is reshaping them faster than ever, with consequences that affect both marine life and human communities worldwide. Coral reefs are bleaching, sea levels continue to rise, and the water's increasing acidity is threatening shellfish and reef ecosystems, issues unfolding right before our eyes. But here's where it gets controversial. While many are rushing to fix the damage with marine climate interventions, these efforts come with risks that are often overlooked and poorly managed. Scientists, governments, and industries across the globe are experimenting with ways to reduce carbon dioxide in the atmosphere and repair ocean damage. Strategies being explored include breeding corals that can tolerate higher temperatures, restoring vital mangrove forests, and cultivating seaweed for carbon capture. These approaches hold tremendous promise but also pose significant dangers. Some might be ineffective, create unfair outcomes, or even cause more harm than good. The speed at which new ocean-based climate solutions are emerging is outpacing our ability to regulate them properly, monitor their impact, or evaluate their effectiveness. This raises worrying questions. Are we investing our resources wisely? Could we be missing a critical window to prevent irreversible ecological damage? In our recent study published in Science, we took a deep dive into current evidence about the risks linked to these marine interventions and explored emerging ideas on how to manage them better. What we uncovered was eye-opening. Not enough attention is given to potential risks, and benefits remain uncertain. Yet, promising tools and planning frameworks are starting to take shape, offering pathways to align ocean-based climate actions with global goals. To give you a clearer picture, marine climate interventions vary widely and are taking place around the world. For instance, efforts in North America focus on increasing ocean alkalinity to enable seas to absorb more carbon dioxide. In Australia, scientists are developing heat-resistant corals for reefs suffering severe damage. African projects are farming seaweed to trap carbon and combat acidification, while in parts of Asia, mangrove restoration aims to protect coastal communities from climate impacts. Additionally, some countries are trying to curb emissions directly by banning offshore oil and gas exploration. Some initiatives are still in early experimental phases, and others have been tested but later abandoned for various reasons, including difficulties in monitoring and verifying results. Each approach brings its own mix of benefits, costs, and risks. Take ocean alkalinity enhancement, for example. It could potentially help draw more carbon from the atmosphere, but accurately measuring how much carbon is actually removed is very challenging. This makes it hard to justify the financial investment and raises concerns about possible harm to local marine life. Coral restoration efforts can boost biodiversity temporarily. However, there's a real chance that these gains won't last as ocean temperatures continue to climb beyond even heat-resistant corals' limits. Moreover, these restoration projects require considerable funding and human labor, often involving energy-intensive methods that unintentionally emit greenhouse gases themselves, which limits scalability. Seaweed farming presents another complex case. Scaling up to remove meaningful amounts of carbon would require huge ocean areas, millions of square kilometers, potentially displacing crucial fishing zones, shipping lanes, and protected habitats. For example, producing 1 billion tons of seaweed biomass might cover over 1 million square kilometers of the Pacific, yet it would only achieve around 10% of the global carbon dioxide removal needed to limit warming to 1.5 degrees Celsius. Furthermore, some experts question whether seaweed farming genuinely results in net atmospheric carbon removal. However, when managed carefully, it can offer other climate advantages like improving local ecosystems and providing alternative livelihoods. Importantly, many of these projects happen simultaneously or overlap geographically, which can lead to cumulative effects and unintended consequences. Such overlaps sometimes marginalize other ocean users, infringe upon indigenous rights, or reduce public confidence in climate policies. Without thoughtful planning and deep understanding, well-intentioned interventions might worsen the very problems they seek to solve. A major challenge is governance, or rather the lack of comprehensive regulation suited to the large-scale and complex nature of marine climate interventions. Most existing laws were created with land ecosystems in mind, and are fragmented or outdated when it comes to the ocean. Far too often, risk assessments and community consultations are missing before projects get underway. The ethical questions involved are profound. Who has the authority to define a healthy ocean? Who will be accountable if a project harms ecosystems or people? How do we make sure benefits like improved climate resilience are shared fairly? At present, scientists, funders, and NGOs primarily drive decisions, with limited input from governments, local populations, and indigenous groups. This imbalance risks reinforcing past injustices and undermining trust and legitimacy. Despite these concerns, there is cause for optimism. Emerging guidelines and best practices from pilot studies on blue carbon capture, where carbon is stored in ocean and coastal environments, are helping shape standards. For example, nonprofit organizations in the U.S. have created codes of conduct for marine carbon removal projects. However, these guidelines are yet to be fully integrated into wider governance systems. There is growing recognition, too, within high-level climate policies that interventions must be responsible, sustainable, equitable, and adaptable. The Samoa Climate Change Policy 2020 exemplifies this approach by committing to help coastal communities adjust to warming oceans while working to lower carbon emissions. The ocean is at the heart of our climate future. It moderates heat, stores vast amounts of carbon, and supports countless species. Yet it's also fragile and increasingly the site of trial and error interventions. If we want to realize the potential of ocean-based climate solutions, we must move forward with caution, humility, and thoughtful planning. Contrary to some beliefs, having robust governance is not a roadblock to innovation. It is the very foundation for it. By embedding ethical principles, inclusivity, and solid scientific evidence into our strategies, we can steer the ocean toward a future that is not only more resilient, but also fairer for all. So here's a question for you. Do you think current marine climate interventions are being rushed without enough oversight? Or is bold experimentation exactly what we need, given the urgency of climate change? Share your thoughts, and let's start a conversation, because the future of our oceans depends on it. Climate interventions to save our oceans. The need for stronger governance. Our oceans are under siege, and the stakes couldn't be higher. Climate interventions are being rapidly deployed to combat the escalating threats of coral bleaching, rising sea levels, and biodiversity loss. These issues are no longer distant threats. They are happening now, with devastating impacts on marine ecosystems and the communities that rely on them. But here's where it gets controversial. Without strong governance, these interventions could do more harm than good. According to a recent study published in Science, the study delves into the array of novel interventions being used to address the climate crisis and the dramatic changes in our oceans. These interventions include efforts to reduce ocean acidity, breed climate-resilient corals, farm seaweed to capture carbon, and restore mangroves to protect coastlines and naturally store carbon. Lead author, University of Melbourne Professor Tiffany Morrison, warns that while these interventions offer hope, they also carry significant risks. Without robust governance, we risk repeating past mistakes, implementing solutions that are ineffective, inequitable, or even harmful, Professor Morrison said. The pace of innovation is outstripping our ability to regulate, monitor, and evaluate these interventions responsibly. To navigate these challenges, the researchers advocate for a concept called responsible marine transformation, a governance approach that prioritizes sustainability, equity, and adaptability. This means carefully weighing the risks against the benefits, resolving ethical liabilities, improving social co-benefits, and aligning adaptation interventions with broader climate mitigation goals. It is crucial to conduct rigorous, comparative studies to assess the climate benefits and risks of these interventions, including their scalability and long-term viability. Co-author, University of Exeter Professor Neil Adger, emphasizes the importance of community engagement. This means collaborating with indigenous peoples and local stakeholders from the outset, ensuring their knowledge, values, and rights shape intervention design and implementation. Professor Adger said, "If these interventions prove viable, we must also develop and apply bioethical protocols that address not just animal welfare, but broader ecological and societal implications of upscale deployment." Professor Morrison was recently awarded an Australian Laureate Fellowship from the ARC to improve global marine futures. And this is the part most people miss: the need for a holistic approach that considers not just the technical aspects of these interventions, but also their social, ethical, and environmental impacts. So what do you think? Should we be more cautious in our approach to climate interventions? Or do the potential benefits outweigh the risks? Let us know your thoughts in the comments below.